accuracy, precision of instruments, and errors in measurements. Systematic errors. The systematic errors are those errors that tend to be in one direction, either positive or negative. In accuracy, precision of instruments, and errors in measurement. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. Every calculated quantity which is based on measured values also has an error. We shall distinguish between two terms, accuracy and precision. In general, the errors in measurement can be broadly classified as A. Systematic errors and B. Random errors. Instrumental errors. Instrumental errors that arise from the errors due to imperfect design or calibration of the measuring instrument, zero error in the instrument, etc. For example, the temperature graduations of a thermometer may be inadequately calibrated. It may read 104 degrees Celsius at the boiling point of water at STP, whereas it should read 100 degrees Celsius. Imperfection in experimental technique. To determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. Imperfection in experimental technique or procedure, other external conditions such as changes in temperature, humidity, wind velocity, etc. during the experiment may systematically affect the measurement. Personal errors. Personal errors that arise due to an individual's bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions. Random errors. The random errors are those errors which occur irregularly and hence are random with respect to sign and size. These can arise due to random and unpredictable fluctuations in experimental conditions. Example, unpredictable fluctuations in temperature, voltage supply, mechanical vibrations of experimental setups, etc. Personal, unbiased errors by the observer taking readings, etc. Least count error. The smallest value that can be measured by the measuring instrument is called its least count. The least count error is the error associated with the resolution of the instrument. For example, a vernier calipers has the least count as 0.01 cm. A spherometer may have a least count of 0.001 cm. Least count error belongs to the category of random errors, but within a limited size. It occurs with both systematic and random errors. Absolute error. Suppose the values obtained in several measurements are A1, A2, A3 till AN. The arithmetic mean of these values is taken as the best possible value of the quantity under the given conditions of measurements as a mean equals to a1 plus a2 plus a3 till an divided by n, which is also represented as a mean equals to summation of ai, where I equals to 1 to n divided by n. The magnitude of the difference between the true value of the quantity and the individual measurement value is called the absolute error of the measurement. This is denoted by modulus of delta A. Then the errors in the individual measurement values are delta A1 equals to A1 minus A mean, delta A2 equals to A2 minus A mean, and so on. The delta A calculated above may be positive in certain cases and negative in some other cases, but absolute error mod of delta A will always be positive. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error of the value of the physical quantity A. It is represented by delta A mean. Thus, delta A mean equals to mod of delta A1 plus mod of delta A2 plus mod of delta A3 till mod of delta An divided by n, which is equal to summation of mod of delta Ai, where I equals to 1 to n divided by n. If we do a single measurement, the value we get may be in the range of A mean plus minus delta A mean. A equals to A mean plus minus delta A mean. A mean minus delta A mean is less than equal to A, which is less than or equal to A mean plus delta A mean. This implies that any measurement of the physical quantity A is likely to lie between A mean plus delta A mean and A mean minus delta A mean. Relative error and percentage error. Instead of absolute error, relative error or percentage error, delta A is used. The relative error is the ratio of the mean absolute error, delta A mean, to the mean value A mean of the quantity measured. Therefore, relative error equals to delta A mean divided by A mean. When the relative error is expressed in percent, it is called the percentage error, delta A. Thus, percentage error delta A equals to delta A mean by A mean into 100%. Combination of errors. If we do an experiment involving several measurements, we must know how the errors in all the measurements combine. If there are errors in measurement of mass and sizes or dimension, there will be errors in density of the substance. Therefore, it is essential to know how errors combine in various mathematical operations. For this, we use the following procedure. A. Error of a sum or a difference. B. Error of a product or a quotient. C. Error in case of a measured quantity raised to a power. Error of a sum or a difference. Suppose two physical quantities A and B have measured values A plus minus delta A and B plus minus delta B respectively, where delta A and delta B are their absolute errors. We wish to find the error delta Z in the sum Z equals to A plus B. We have by addition Z plus minus delta z equals to a plus minus delta a plus b plus minus delta b. The maximum possible error in z, delta z equals to delta a plus delta b. For the difference z equals to a minus b, we have z plus minus delta z equals to a plus minus delta a minus b plus minus delta b, which is equal to a minus b plus minus delta a plus minus delta b. Therefore, plus minus delta z equals to plus or minus delta a plus or minus delta b. The maximum value of the error delta z is again delta a plus delta b. Error when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Example: the temperatures of two bodies measured by a thermometer are T1 equals to 20 degrees Celsius plus minus 0.5 degrees Celsius and T2 equals to 50 degrees Celsius plus minus 0.5 degrees Celsius. Calculate the temperature difference and the error therein. The answer is T dash equals to T2 minus T1. That is 50 degrees Celsius plus minus 0.5 degrees Celsius minus 20 degrees Celsius plus minus 0.5 degrees Celsius. Therefore, T dash equals to 30 degrees Celsius plus minus 1 degree Celsius. Error of a product or a quotient. Suppose Z equals to AB and the measured values of A and B are A plus minus delta A and B plus minus delta B. Then Z plus minus delta Z equals to A plus minus delta A into B plus minus delta B, which gives AB plus minus B delta A plus minus A delta B plus minus delta A delta B. Dividing LHS by Z and RHS by AB, we have 1 plus minus delta Z by Z equals to 1 plus minus delta A by A plus minus delta B by B plus minus delta A by A into delta B by B. Since delta A and delta B are small, we shall ignore their product. The maximum relative error is delta Z by Z equals to delta A by A plus delta B by B. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers. Example: the resistance R equals to V by I, where V equals to 100 plus minus 5 volt and I equals to 10 plus minus 0.2 ampere. Find the percentage error in R. Answer is the percentage error in V is 5% and in I it is 2%. The total error in R would therefore be 5% plus 2%, which is equal to 7%. Error in case of a measured quantity raised to a power. Let us suppose Z equals to A square. Then delta Z by Z equals to delta A by A plus delta A by A, which is equal to twice of delta A by A. Hence, the relative error in A square is 2 times the error in A. If z equals to a raised to the power b into b raised to the power q by c raised to the power r, then delta z by z equals to p into delta a by a plus q into delta b by b plus r into delta c by c. The relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity.